In this video I will show you how to solve the trigonometric basic equation tangent x equals a. In the end of the video you will also see one example, which is tangent x equals the square root of 3, which I will solve. Here you see the graph for the function fx equals tangent x. As you recall, tangent x is not defined for plus minus pi over 2, plus minus 3 pi over 2, plus minus 5 pi over 2, and so on and so forth. As you remember, tangents is defined as sine over cosine, so when cosine x is equal to 0, tangent x is not defined. And that's where you can see all these vertical asymptotes here for plus minus pi over 2 and plus minus 3 pi over 2, and so on and so forth if you will continue this picture. Let's consider we have another function, gx. Gx equals a being a certain number. And if I insert the graph for gx equals a, then if a is whatever number, it could be, for instance, a equals 3, then the graph will be this horizontal line which you have here. And then you see all these intersection points between the graphs for fx and gx, which are the ones which I have indicated here. And of course there will be many more if you prolong this picture here of the graphs for fx and gx. All these intersection points will be when the function fx is equal to the function gx. And since fx is defined as tangent x and gx is defined to be equal to a, if we can solve this small equation here, then we will exactly find these intersection points between the two graphs for fx and gx. When we looked at the basic equation sine x equals a when we looked at the basic equation sine x equals a and cosine x equals a, we saw that we had a restriction to the number a if we should have any solution to that two basic equations. We saw that a has to be in between minus 1 and 1. As you can see in the graphs over here, we don't have any restriction to the value of a. No matter what a is equal to, we will find intersection points between fx and gx, no matter what we define a to be equal to. That's why, as noted up here, we don't have any restrictions to a must belong to all our real numbers. The only restrictions we see here is the restrictions to x due to the definition of tangents, so x is only defined for all the real numbers except from plus minus pi over 2, plus minus 3 pi over 2, and so on and so forth. So let's see if we can figure out what the solution will be to the basic equation tangent x equals a. And I will start by looking into one example, and then we will afterwards look at the general picture. The example I have chosen to include is the trigonometric basic equation tangent x equals square root of 3. And as always, we have to look into restrictions to our variable x. X belongs to all our real numbers except from plus minus pi over 2, plus minus 3 pi over 2, and so on and so forth. Let's try to visualize what we are dealing with. I'm sketching the unit circle. Here we have it. And then when we're dealing with tangent, we remember that we have to insert the vertical tangent in the point 1.0. That's the one which we have here. So in this example, we're looking for values for x where the tangent value is equal to the square root of 3. The square root of 3 is approximately 1.73, so it's 1 is here, then 1.73, or square root of 3 must be up here. So that must be the angle I'm looking for, must be this one here, x. Alright. So we also recall from when we talked tangents that we have another solution, another angle, which is the one I have here, which is pi plus x, which also have the tangent value being equal to square root of 3. So let's try to solve this one up here. If tangent x is equal to the square root of 3, then x is equal to inverse tangent square root of 3 plus p times 1 pi. We remember that tangent is a periodic function with the period 1 pi. So the length of one repetition, one cycle, one period is equal to 1 pi. Alright, so inverse tangent square root of 3 is equal to pi over 3 plus p times pi, and p of course has to be one of our integer. So that's how you solve the trigonometric basic equation tangent x equals a. Let's look into the general picture. If you have tangent x equals a, you have the restriction to x as we talked about, no restrictions to a, then x is equal to inverse tangent a plus p times 1 pi. For every time you take a repetition which is equal to 1 pi for tangents, then you get a new solution, a new intersection point between the two graphs. So that's how you solve the basic equation tangent x equals a. If you have any questions to how you solve the basic equation cosine x equals a or sine x equals a, then look into the two videos which are related to these two topics. That's all for now.